rolling. So welcome everybody. This is module 1 for our session, and I just handed out, if anyone still needs to get a copy of the slides that we have there, I handed out the PowerPoints that are here, and what we are going to be covering tonight is intro to Java and using objects. And these are our basic topics that we're going to be covering. Intro to Java, we'll talk about variables and data types in programming, expression and assignment statements, creating and using objects. Java is what we call an object-oriented programming language. So objects is a very important part of programming in Java. We'll also talk about strings, which are words, characters, strung together, which I call strings, and then also mathematical functions in Java. And one thing to keep in mind as we're going through this in all the different modules here is we're going to be doing so I'm going to write some programs up here and then have a couple of assignments. If you've already looked at module 1, you've seen the assignments already up there, but there are going to be some programming assignments. On the exam, just to reiterate, you don't have to write any code. You just have to be able to read it, understand it, what does this do, what would go here, missing pieces, things like that. But taking a little bit of time to write and actually do some of the project just really gets you into it. It's the old adage of, why do cars go 120 miles an hour, right? Because even though the speed limit's 70, and I ask my kids this every time, and none of them can answer. And I'm going to assume you all know the answer to this because you're teachers, so I'm not going to ask anyone. But you all know the answer to that. The answer is because you want cars to go 120, so going 70 is no big deal, right? So the car's not straining at its maximum possible, ability. At 70 miles an hour down the road, the car's shaking and wheels are falling off and everything. But it can go 120, so driving 70 is no big deal. So I want you to be able to go 120 so that you can take the exam. Going 70 is no big deal. So we are going to be doing some code writing and things like that on our projects, even though the exam is just going to be answering questions about code and filling in the blanks and things like that. And hopefully that gives you a large level of confidence when we actually take the exam. I also, speaking of the exam, got word that our last class is on May 18th, but we got an extension on the grant that you can take the exam anywhere up until it's either August or October, one of the two, and now I forget. Remind me during the break, I'll look that up, I believe, but it got extended. So even though our last class is in May, you don't have to take the exam right away. You can give it a couple weeks, take it in May, June, or July. It might be August, it might be October. I have to go back. Faith emailed me and I meant to write it down. I'll check my emails. Anyway, so that's what we're gonna be, so we'll talk about that later on when we get in there. So let's go ahead and dive into this and what we're gonna be doing. So some additional resources, in addition, we're gonna go through all the topics here, some other resources that you'll have access to help bolster some of these. Study.com, for those that might have just come a little bit late, she's put the purchase order out for the Study.com licenses. We have not gotten those back. She will email you all of those. It's an individual logon for Study.com. They have a lot of resources out there. Some of the stuff that we'll be talking about will be in these two Study.com courses. And then CS Awesome, which is the online textbook, which I talked about in the last session, is also, we're going to be doing the first unit in CS Awesome, covering those topics. Tonight we'll actually be doing the first 2 units. We'll do the first one, take a break, and then we'll do the second one there as well. That's what we'll be covering here. These are the different resources that we have. If you have not, how many people signed up for CS Awesome already? Most of you, fantastic, thank you. But if you haven't, and hopefully had no problem with that, I didn't check to see who was signed up and who wasn't signed up because I knew we were going to have more people that needed to still. But hopefully you got started there, you put a username, password, and you see the online class that's there for CS Awesome. We also mentioned developing programs at home, your own development environment. This is called JGrasp. This is on our welcome documents. There are these 2 files. One is the Java Development Kit. The other one is the IDE, the Integrated Development Environment. That's where we actually can write some programs on our own. That's what the professionals do. They use all different types of IDEs. This is a really good education one that we use. Again, if you have a school-issued device and not your own laptop, you will probably have to get your tech support IT people to install that for you because it does require admin privileges. If you have any problems doing that, just email me, or if your tech person has any questions, just have them email me. I'll be happy to talk to you about that individually and get that on. Has anybody got JGrasp installed?
Yes.
A lot of you as well too, great, no problems. And if you don't, no problem, get that taken care of. We'll use that a little bit starting this week as well. So that's where we're going to start. We're going to start with talking about what our Integrated Development Environment, or IDE, is. And it's called JGRASP. And why we use something like this is because the same reason you wouldn't use Notepad to write a term paper, right, for a class, is because you would use like Microsoft Word or Google Docs because it has all the nice formatting, paragraphs, capitalization, it indents things well and lines it up. That's what JGRASP does. You'll notice up here there's a program that color codes things. And when you write programs, it helps line things up nice for you as well. Even if you understand nothing that's up there on the screen right now, that's a basic program that we run in JGRASP. And here is our first program that I'm going to go ahead and load up and show you what it does. This is and the individual parts we'll talk about here, but all of our programs reside within what we call a class. And I'll explain more about that later. But the name of, it's public, meaning that Java has access to it as does anybody else that is sharing your system here. The name of our program is called Hello Tester, because it's going to test out saying hello. So it can be called anything you want. Public static void main string args is a long term just saying this is where we're going to start. And we can break down what those individual pieces mean. We don't need to worry about that right now. But just know that public static void main string args means this is where our program is going to start. You'll notice we have things called these curly braces. We open curly brace. We have some code here. This is our actual code. And then we have some code, some closing curly braces here as well too. We'll break down the details of this. This basically just prints out the words "Hello World." It's a very famous first program that beginners usually write, and they've accomplished something, and they've written a line of code here as well. And we'll get to that here in a second. When we write our programs, it's like with any language, it's going to seem like the syntax is the really hard stuff to understand. He just said curly brace, and then there's something with a system, and there's a quotes, and there's public static void main string args, and what does that mean? And those are all the syntax rules. These are our rules of grammar. That's what we're actually learning here in Java. We're learning grammar rules. It's going to seem like that's the hard part at first, but you pick up that pretty quickly as we go along. Those are the rules. I before you accept after C, and even that's not a rule because English is a terrible language, and there's like 50 million different exceptions to that we all know. But the semantics, the meaning, the understanding of what does a program actually do and mean, that's where it gets really difficult. That's when we start talking about the algorithms and the processes that we're making our programs do. We know you ain't nothing but a hound dog. That's horrible English, but you know what it means, right? Java isn't as forgiving as an English language. Everything has to be syntactically correct. La plume de montante is like, and if anyone speaks French, my aunt's feather is on the door or something like that. Any French speakers? No, that's what it says. It says the aunt's feather is on the door, I think. We'll go with it. But it's what it actually means. And that actually is the harder part. So it's going to earlier on, it's easy to get caught up in the syntax and go, oh, I'm having a hard time with this. But once you get rolling into it, then you got to think about it's the algorithms, it's the process. What are the steps I do? That's actually the part that gets a little more difficult. It's like I can teach you Spanish, but I can't teach you how to write a best-selling novel in Spanish. That's tougher, right? So we do the grammar rules. That's the easy part. So that's what we're going to focus on a lot. It's going to seem like the syntax is harder, but stick with it. After you start doing it for a little while, it comes really, really quickly. Our simple program that we just saw on the previous slide, and I'll break it down here in a second, we saw where it had public class and it had the name. We noticed it had curly braces in there. Public static void main string args, that's where our programs start. You may have noticed that there was something that looked like English in here. Display a greeting in the console window. Not Java, English, because I had two little slashes in front. We call this a comment. Commenting your programs or little comments that explain what your program does is very helpful throughout your code as well too. Then we did something called a method call. Some languages call them procedures if you're familiar with other languages. Object.method name, we'll talk about that a lot later on today. And we have something called a parameter or a value that's being sent. and we're sending it hello world, and this has its own functionality. It's going to print the words hello world to the screen. So I'm going to go ahead and, well, let's talk a little more about it first before I run it. So a couple of syntax rules that we're going to start off with right off the bat is that all of our programs start with a class. You saw that public class hello tester. All of our programs start that way. Every class must have what we call curly braces, the little indentational curly braces here that we have. Lining up the braces and using indentation makes your program very easy to read. And then all of our programs start with public static void main string args, which basically tells Java, hey, this is where we're going to start the execution of our program. And, oh, you might notice also all of our Java statements are going to end with a semicolon. If I go back to that one program, here's my command, there's a semicolon at the end. That's our way of saying our statement ends here. And we'll see that a lot. All of our statements will end with a semicolon. So I've just thrown about 16 different syntax rules at you, but you'll see them come up a lot as we go through a lot of things tonight here as well, too. So, hi, welcome. Hello. Yeah, the seats up here on the side, anybody like, it's fine. Good, there you go. In addition, we saw that system out. System out has two different types of printing methods. One's called print, which means you print something and then it stays on that line. And the next one is called print line, which prints it and moves to the next line. And it says, well, that's not really a big distinguishment between the two. It is, and we'll see some examples of that where we use print line a lot to print different things to the screen. So once we type in our program, what do? Well, and I know I'm going through a lot of slides fast. I'm going to go back and run through this whole code here in just a moment. It says source code to running program. So whenever you type in a program, we type our program into our editor, our IDE that we have, and then we have what's called a source file. Every time you type something in, like in Word, you create a doc file, right? In PowerPoint, you create a PPT file, PPTX file. In the editor, you create a .java file. And that's really, it's just a text file of the code that you typed in. And then in your IDE, you hit the plus button and it activates the compiler. And I'll show you how to do that in a second. And what that does is it takes that Java program and it checks it for syntax rules. It checks to see if there's any errors in your program, any rules of the language that you violated. Also make sure everything's lined up right, and it creates what's called a class file. And the class file, you'll notice it'll pop up the name of your program .class. And that is something that's in machine language now for the Java virtual machine to understand. And then what it does is it links it with what we call the Java interpreter and any library files, like that system.out that we saw, that's located in the library. And then when you press the little run guy in JGrasp, it runs the program, or what we call executes the program, and it then follows all the instructions that you gave it. Hopefully it does what you want it to do, and it goes from there. Let me show you an example. So this is JGrasp. And if I were to create a new program, and I'll show you this later on, but from here you can do File, New Java, and it'll create a brand new Java file up here. It hasn't been named anything yet because I haven't saved it, but I actually have the Hello Tester program already done. So I have it over here. I'm going to double click on it, and it's going to open it up. So here, make it a little bigger. Here is the Hello Tester program that we just had. Public class Hello Tester. You notice it's in a file called hellotester.java. The file name matches this name right here. Public static void main string args. This says display a message. That's my comment. And the one line of code this does is it prints hello world. So I'm going to go ahead and there's two buttons up here. There's the plus button and the run button. This is to compile it, and this is to run it. It's also in the menu here under build. There's a compile and a run over here, but these buttons are fun to use. So we just hit the plus button, and if there are no errors, it tells me operation complete. Oh, no errors. So now I'm going to execute or run this program by pressing the little running man, and don't hold your breath. There it is. Hello world. Hey, we've got our first program. And if you get that running in JGrasp, fantastic. That's the first thing you got. You have a program under your belt. We've got our first Java program. Now, if there are any errors, we need to fix them. So let's go back into the slides here, and let's talk about different errors. The first type of errors are, as I mentioned, the syntax errors, rules of that violate the programming language. Like if I type in system.ouch, right? It'll say, what is system? We don't know what that is. That's an error. Or any guesses what's wrong with the second line? System.out, hello, yeah.
You're missing the other quotation.
Quotes. So you may have noticed anything I wanted to print had to be in double quotes. I got one, I don't have the other. So that's what we call an unclosed literal. So what happens there is if let's put some syntax errors in. Let's say I do system dot something that's not valid, and it says, wait a minute, what is, no idea, variable, oh, it doesn't understand what that is, it's got no idea. So so we need to fix that. So that's a violation of our syntax rules. So we're going to change that back to system.out. If I didn't have that closed quote here and then tried to compile it, it would say unclosed string literal. It tries to tell you what's wrong. It doesn't always know, and sometimes it points in the wrong spot. But try your best. There's an error there somewhere, right? So let's go ahead and fix this. Now that's a syntax error. A logic error, or a different type of error, might be something that Java doesn't think is wrong, and it runs it, but it wasn't what you wanted. Maybe you have your calculation wrong. Maybe you gave it the wrong statements. I have in the slides here, what if I just did this and said, hell, totally different meaning now, right, from hello world. Now, if I build this, hey, there's no errors. If I run it, it says hello world. Now, they have had, that's a lot more appropriate, I gotta be honest with you. But it works, right? So that's what we call a logic error or a runtime error, because now what happens here is it's something that Java says, I'm just doing what you told me to do, and it worked and it ran. It just might not be the outcome that you wanted. So we call that a runtime or a logic error here. Some other common syntax errors. Java is very case sensitive. So things like capital S system. You'll use system.out to print line a lot to print things out. It needs a capital S for system. Missing a semicolon is a big one. It'll say like a semicolon expected and there wasn't one. Usually it'll say on the next line that there's an error. And you look up, it says, well, wait, you've got something else down here. I was expecting a semicolon. Oh, because you forgot to put it on the line above. So that'll be a common one. Here, we already talked about this. I forgot the close quote. Another big one that a lot of people make, if they put a space in their file name, it'll say the file name doesn't match the program name. You can't have a space there. But the name of the program has to match the name of the file exactly. And it's second nature to put a space in there, right, between hello and tester, but Java doesn't like to have space in its file names. So if you're trying this at home, this is a good slide. This is everything I just did. You can start the JGrasp IDE. You go to File, New Java, which is, I kind of showed you. There's a step-by-step instructions to try this on your own. You type in the sample program, the hello world, right from the slides that are there. And then you can either select build, run in MS-DOS. That's a pop. You actually don't need to do that. And this is line numbers. It pops up the line numbers. These two are optional. But save as, it'll save it as, you can save it as the name of your file. I always recommend saving your stuff on OneDrive, if you're familiar with using OneDrive, just because that way you can access your programs anywhere, you won't lose them if your computer crashes. We call this Hello Tester because the program was named Hello Tester. We click on Build Compile or the green little plus symbol, then you can click on Build Run or click on the running man. It's I think that you just press the buttons, and then assuming no errors, you got your first Java program. Yes?
So when I did that, the build, 1, 2, 3, 4, the fourth one down says select build, run in MS-DOS window.
Right.
I didn't have that.
Yeah, you don't have to. Here's what happens. If I go to build, run in, it says they've changed it. It's now run in Windows console.
Okay, that's what I meant.
No worries, great comment here. What happens when you select that? That's just a newer version of the latest version of JGrasp. They changed the wording here.
Is that the one we need to select?
You don't need to. If you do select, let me show what happens when you select it. Now, when I run it now, it pops up in a window over here. I had to drag it. It was on my other screen. Hit key to start, and it says hello world.
Okay.
If you want it to pop up in a separate window, some people like that. I like to have it all in the one right here. It'll just display it down here. So if I unselect that now, run in Windows console, and then run it, it just prints it up down here.
Okay.
And I'm gonna brighten the day and change that. Oops, not down here. Up here, change that back to hello. Better vibes there. And then, all right. So yeah, if you, they changed the menu option. It's run in Windows console, and I noticed at the beginning of the year, I didn't update that slide from last session, from last year's slides when we had that. So
I don't have that choice on mine.
build run in Windows console. Do you have build run in MS DOS
It says
window?
File, edit, view, project, setting, tools, windows, and help.
So you have build or you don't have build? On JGrass? Really?
You don't have a program.
Oh, I have to type.
Oh,
in
you got, yeah, sorry, yeah, you have to do the file new first, all that, do the other steps first. Yeah, it'll change the menu based on if you actually have a program up there.
Gotcha.
Good
I'm
call,
sorry.
good call, nope, that's great. And this is the type of thing we'll be doing, all that like little tiny answering questions, and I will be here after we're done. If you have like specific, I could not get something to work, let me know. I'll be here I'll usually be here early too, but I'll be here afterwards at 7:30, and feel free to email me anytime. Give me a chance to ignore my students for a minute. I'll be happy to, during my break or my plan, I'd be happy to email you back. It's seriously not a problem. I would definitely like to help you out. So don't hesitate to ask. They pay me to help you during the week. So please let me do that. You're not bothering me at all. Anyway, so that's our first program. So go home and try that. If you haven't done that already, make sure you try that. All right, so now let's get into some more Java stuff. So that was our first basic program. We saw there was a class. We saw there was a public static void main string args. We had curly braces. We only did one command. It said print this. That's all we did. We got to do a lot more to make these programs more meaningful. The first thing we're going to talk about is variables. What's a variable? It's a way for storing information. In math, we use variables. We talk about unknowns, right? So like your x and y, we solve for x. Or what can x be and what does x represent? It's kind of like that same idea. Variable is a storage location. It's a memory location that stores in a particular value. We have three basic types. Two of them are up here. That third one's a fake. It's not really a basic type, but it's a string. But we'll talk about that. So we have int, which is an integer. Integer is a non-decimal number, positive or negative. And we have a double. A double it stands for a double memory location. It basically means it's a decimal number. So a double is a decimal number. So notice I have a variable there. Looks like it's num days, 365, represents the number of days in a year. I have a variable called sales tax for 6.5, and I have a string called word, which is actually word in quotes. So we'll talk about string variables here as well. You'll notice that these are statements, you can tell because there's semicolon at the end. And what I'm doing here is I'm actually creating these memory locations, and that equal sign is assigning a value and putting it into the variable. So that's our type, integer, double, or string. That's our identifier, the name of our variable, and that's our value that we're putting in there. And that equal sign we use to assign a value. We'll talk about that here coming up. In math, an equal sign denotes equality, something on both sides. Not what it means in Java. In Java, it says take whatever's on the right-hand side and put it into the variable on the left-hand side. It's an assignment statement. We'll see that here coming up. So here, just to break these statements down a little bit, our simple data types, our integers, our real numbers, or our decimal numbers, and our doubles. And then our third simple data type wasn't string. It's something called a Boolean variable, and this is the value of true and false. And a true and false value is used a lot in programming to indicate like something's on or off, or 1 or 0, or true or false. And it's used to evaluate pathways, and we'll get into that a lot in the next session as well. But that's just it doesn't represent the word true. Notice there's no quotes around this. It's actually true as a value in Java. Something is true or something is not true, which is false. You'll notice I have a variable called GPA here, double GPA, and I didn't give it a value, but then later on I could assign it a value of 3.57. Here I've got an integer variable called age. I gave it a value 4. Oh, and then I gave it a different value, 24. Guess what happened to the 4? It's gone. I've got, think of it as a memory location, think of it as a bucket. I have a value into it. When I want to put another value in, it overrides or deletes the other value, and it holds the new value now. So these identifiers, the names of my variables, are what we use to identify a variable, but we also use the same rules to identify a class, or what we call a method, and we'll see those later. But some rules for identifier, and these change. These can, so it can be made up of letters, digits, and the underscore. Cannot start with a digit, cannot use these other symbols. You can't have spaces. You can't use reserved words like the word public. We saw that was a Java keyword, so we can't use that. And they are case sensitive. So if you ever come up with a variable name like age or GPA or num days, whatever, you just have to follow those rules. I think in the later version of Java now, you can start with a digit. I haven't experimented with that yet, but Java has a whole bunch of newer versions and they're adding tons of new features. I think you can start with a digit now, I'm not sure. But normally we'll just use letters and digits, and we'll use the underscore occasionally here. We will do something called that by convention. Our variable names tend to start with a lowercase letter. That's a convention, doesn't have to. And we use what's called camel case. So you'll notice how when I had like num days, the D was capitalized, and sales tax, the T was capitalized. That's just so we can identify. If we have multiple words in an identifier, we capitalize the start of each new word so it's just readable. Otherwise, it looks like those kids' text message where they just run all their words together and hashtag blah, 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 blah. You have no idea what that means because they should use camel case. We'd understand it. So that's how we make up our identifiers. And then as I mentioned, the equal sign is the assignment operator. So that this is one of our first syntax rules that we're learning here with variables, is that we declare a variable by putting the int or a double in front of it. We give it a name, and then we use the equal sign to put a value into that location. So here I've got my lucky number is 13, and then the next line, no, I changed my mind, my lucky number is 12. So let's just take all of that and put it into one big old program here. And now this is a lot. So we've done a bunch of things here. Here is a public static void main string args, and we're gonna show you I'll show you the example one program we have. I've got an integer called score that has the value 0 in it, right? This is gonna print the score is. Now remember, I kind of briefly went over this, but it's a lot easier to show it in context. There's a difference between print and println. Println means print line. Print means print it and wait. Whatever comes next is going to stay on the same line. Print line means print it and then go to the next line for whatever's coming next. So this is going to print out the score is and then wait on the same line, and then it's going to print the score and then go to the next line. We'll run this and see what it looks like. Here I've got a price, $23.25. It's a double. I assigned it a decimal number. I'm going to print line the price is, so the price is going to go below it now, because print line, don't wait on the same line, go to the next line, print line, print my price on the next line. I changed my price, $11.37, printed it out, it's going to have a new price value. So you're going to see a different number printed out. And then I've got a Boolean variable called 1. It's false, so I didn't win. It's going to print out 1, which is just going to print out false. It's going to print out the word false, even though it's a value. I then assign the value 1 to be true, and it's going to print that out. Let me show you what this looks like. It's a lot easier to see it when we're running code here. So I'm going to pull up JGrasp. I have example 1 right here. So this is, and all of these files, if you want to play around with them, are in module 1. So anything that you see me use in class is right there on eCampus as well. So you can download this and run it. So you'll notice if you want to make a prediction here, what is this going to print? Clear that out. So we have some of the score, price, as we said. So let's go ahead and run this. And I'll scroll up here a little bit. So it says the score is 0 because that was print followed by a print line. So because it said print, it printed out the score is and waited. And then it said print line 0. Print the 0, go to a new line. And then it said the price is $23.95. We print line the price is. So it did the price is and went to a new line, and then it printed out the price and went to a new line. And then it changed my price to $11.37, and printed out my price again, so now I got 1137. So what the old one, the 2325, got erased, and now price contains the value 11.37. And then notice I've got a Boolean variable called 1. I printed out 1 and it said false. I changed 1 to true, and then I printed out the variable and it prints true. So when I print out something in quotes, you notice what? It prints out exactly what's in the quotes, right? But what happened when I said print out a variable? It printed out not the word price,
But
the contents that's in price. What if I change this to say the score is, and I put this in score in quotes? I didn't mention this because I figured, see if we pick it up, right? So now what happens if I do this? What's going to be different now when I run this program? I'm going to build it.
It's gonna say score.
It's going to say the score is score, right? Because it's quotes around it. So that's a string value. So I'm going to change that, and notice it changes color too. Yours isn't purple. It presents better in purple. I think the default colors are like black and like a light green, whatever they are. There's a whole color option. You can change the colors. When I use this in class, like the purple shows up a lot more brilliantly. So, but anyway, yeah, that's a full. Now look at this. We just did a program that had 1, 2, 3, 4, 5, 6, 7. You know what I can do? View line numbers. If you go under view, I mentioned that was here. Line numbers. I click that on. Oh, that's really good. So if you get an error, it tells you what line number it's on. So there is. It's about 11 lines of code. That's all there. And hopefully, right now, tonight, here, you're able to understand everything that does. You might say, I'm going to forget all this tomorrow. That's okay. That's why we record this, and that's why we get a chance to practice all this as well, too. I'm just making sure we're still recording. Yes. Good. Questions so far? Good here? We're going to keep going. Got lots to do. All right. So now, let's go back. So that was our first program. And this is what it printed out here. Yeah. So the score is 0, the price is. So I put, have this here. This is also, again, when you run that program, you'll see that's what it ends up printing out here as well. Let's talk about some operators. So we got these numbers now. We have these variables. They hold numbers. We can also do things like some mathematical operations. So Java has a bunch of operators and mathematical operators that are very similar to the ones that you're used to. I say very similar because there's a couple slight differences. Addition, subtraction, multiplication, division, and modulus. It's not really modulus, it's a remainder. If you're familiar with the modulus function mathematics, it's the remainder after you divide. Remember that old school math you first learned? You did long division, and you said like 5 goes into 22. You would say 4, and then you put a big R2, the remainder. That's what modulus is. It's really, and again, the percent symbol, it's the modulus function. It gives you the remainder when you divide. Let me show you some examples here. A couple of addition, subtraction, multiplication, they work exactly like you think they do. But division and remainder are a little bit different. With division, the slash is my division operator. If one of the numbers is a double or a decimal number, you will get a decimal answer. But if one of the numbers is, or if both the numbers are integers, you will get an integer number. And I'll show you an example here. So 7 divided by 4, if they're both integers, is 1. No remainder. You think, what good is that? It actually comes in very handy in a lot of programs when you don't want to worry about the decimal and the remainders after a decimal point. We have a modulo, or the mod function, where 7 mod 4 is 3 because 4 goes into 7 one time with a remainder of 3. 31 mod 10 is going to give us an answer of 1 because 10 goes into 31 3 times with a remainder of 1. And those are our basic math operators. I've got another program to show you some examples here. What does this print? So take a second, look at some of these, and if you want to write down maybe on the slides like what you think these will print out. These are all print lines, so they're all going to print on their individual lines. And then I do a little bit of calculations in here. Oh look, I did a calculation and assigned it to a variable. Calculation, assigned it to a variable, and then I did some calculations right in my print line here, so it'll do the calculation before it prints the result. So this one, what do you think print line 2 plus 3 is going to print? It's gonna print 5. It's gonna do the calculation for us. Take a second, see if you can figure out what these do here, and I'll pull up the program, we'll do it together. Now be careful with like integer division. Remember and I can use variables here. It's going to use the content of these variables. First divided by second. And whatever's in third, which was second plus 9, and second was 8 minus 6. So some calculations here. But remember, these are third and second are both integers. So it's going to give me an integer here. And then this actually here is going to follow my order of operations. Got to be careful on that too. All right, ready? Go ahead and run this. See what we get. And it's going to print out 5, because 2 plus 3 is 5. 2 minus 3, negative 1. 2 times 3 is 6. 2 divided by 3, careful, is 0.6666, right? But it gets rid of the decimal, so it's just 0. So 2 divided by 3 is 0, integer division. So that's a little tricky here on that one. So that prints out 0. Second is 8 minus 6, so second has a value of 2. And so what I would do is and this is a very common thing you might get asked on the exam. Here's a marker. And when you go take the exam, you get like a little whiteboard, and you can write stuff on. So something good to write on here would be, oh, okay, I got second. Second is going to be 8 minus 6, so second has a 2 in it. Let's see, first is going to be 3.5 times 2, and it's a double, so that's going to be 7.0. It's a decimal number. And then third is going to be, second plus 9? Second is 2, plus 9 is 11. Right? So now we're good, and I don't have the rest of the code up there. But that's good to keep track of on a whiteboard as you're trying to trace code, because there'll be a couple questions like this. And now it's going to ask, what is first divided by second? So we said what first was 7.0 divided by second. So one of them is a double. So second's a double. So 7.0 divided by 2, 3.5 gives me a double. However, third divided by second is 11 divided by 2. 11 divided by 2 is just going to be 5. No decimal, because they're both integers.
And
right?
Modulus?
And then modulus is not up here, but yeah, but if it was modulus, then it would just give me the remainder. So if it said like third mod second, it would give me 1 in this case. But so it's not going to, so it's going to give me no remainder. And then here, first plus second times third is like you see those on Facebook, all like the people who don't understand order of operations, they get like big arguments over what comes first. So it's going to be second times third is going to get multiplied first. So second times third is going to be 22, and then plus first, which is 7.0. So because it's one of them's a decimal, I get 29.0. So those are my values. That's a very typical type of question. What does this print? What does this calculate? And that'd be a good question on the certification exam, just to, do you understand how variables work? Do you understand how print works? How mathematical operations work? That type of thing.
So, can I ask a question?
Sure.
Up the top, the print line, the second one, So
Yes.
does it matter? I guess I didn't realize it would do negative versus positive. I just assumed everything would come out as positive.
Nope, so for integers, negatives and positives.
Okay.
Yep, definitely. Which is why I put that in there, because we hadn't seen one yet,
Yeah.
right? Exactly. So it will come out as a negative. So 2 minus 3 will print out -1. Cool. All right, a little bit more into here. So, this is the answers up here as well too. Couple other small mathematical operators. One of them is called the increment and decrement operators. We can add numbers together and everything, but adding by 1 is very, very common, especially as we're counting things, we add by 1, or if we're visiting different memory locations, we'll see this when we talk about repetition statements. Adding 1 is very simple, or is very common. So one thing we can do is we can say, so this way we would normally add 1 to nickel, we'd say nickels equals nickels plus 1. So if we were counting how many nickels we had. This statement right here drives a math teacher bonkers, because that makes no sense. That can't exist in math, right? Because something cannot equal the something plus 1. X can't equal X plus 1. But equals does not mean equality here. It means assignment. So take whatever's on the left hand, the right hand side, and then put it in the left hand side. So let's say I had 12 nickels. Then what's it going to do? Take the 12, add 1. I now have 13 nickels in nickels. So that's how we add 1. And basically what it does is to that memory location, it adds 1 to it, stores the result back in that memory location. It's so common. Yes?
Is nickels a specific Java word?
No, just I was making up a variable name. Yep, good call. Just any, like if I was using it to count anything, days or nickels or pennies or whatever I wanted to, yep. Another thing that I could do, because programmers are really lazy, and counting by 1 is very, very common. Nickels equals nickels plus, that's a lot of typing. You know what we can just do? Nickels plus plus means the same thing. It's a Java shortcut. It means the same as nickels equals nickels plus 1. You could just say, whatever your variable is, days plus plus, counter plus plus. It just means add 1 to it. So it basically means the same thing it does here. There's also a decrement operator, a minus minus, which subtracts 1. There is no plus to add 2, or minus to subtract 2, just the plus and plus minus. There is, however, and these are on the next page also, so nickels equals nickels plus 1, we could say plus or minus instead, and that's the same as that. Increment it by 1 or decrement it by 1. You'll see these in some code examples. Another shortcut we have is, what if I don't want to add 1, but if I want to add a variable and another variable together and store the result in here? I could do it like this. I could say my purchase is equal to whatever my purchase was plus the new amount that I'm adding to it, and that's my total purchase now, right? So I can do it that way, or there's a shortcut. I could say purchase plus equals amount. Students tend to get tripped up on these. The plus equals and the minus equals and the times equals tend to throw them a little bit. But it's basically just saying, if you say purchase plus equals amount, it means add it to this and assign. Subtract it from this and assign. Multiply it by this and assign it. So that's basically what these are doing. They're shortcuts. Some students prefer not to ever use them. However, on a test, on your certification exam, you have to know how to read those. So if someone said, hey, purchase plus equals amount, you knew that there was $20 in here and amount was $7. Well, now what's going to happen? Purchase is going to be $27, because purchase plus equals means adds to it and assign it. Yeah?
Is division not on there on purpose?
No, it's just because I didn't put it on there. All of the operators work exactly the same. Divide works exactly the same too. One other, I say one other, but there's a couple here. Another mathematical function we'll talk about is something called casting. Variable types matter a lot. So for instance, I can't just say double total equals a lot. That's a word, right? A lot. You can't say much or, bunches. It has to be a number, right? It has to be 7.2 or something like that. However, sometimes we want to take an integer, a no decimal number, and turn it into a decimal number, or vice versa. So we can do something called casting. You'll see this come up in code a lot, where I take whatever my number is, and I say, I want to make it an integer. And if I put in there, make it an integer, that means it'll get rid of the decimal point for me. And in fact, if I don't have this, like for instance, I have total is $1.59. So I want to know how many pennies is $1.59. Well, I created a variable called pennies, int pennies, and I want that to represent the number of pennies in my total, which is $1.59, right? So what do? Well, I say total times 100, right? That's going to be 159 pennies. But it'll actually be 159.0, right? I don't want the 0.0. So I say make it an int, and it's going to get rid of the 0.0, and it allows me to store my value in pennies. If I don't put that int there, Java's going to say, hey, you're trying to put a double into an int, square peg, round hole, that doesn't work. No, Java, I meant to do this. I meant to make it an integer, put an int in front of it. By the way, these both work. Which one does what I want it to, though? The second one or the first one? First. So here's what happens. If this one will multiply it by 100 first because of the parentheses, and then make it an int, so it'll be 159.0, get rid of the 0.0, 159. This one will actually casting, order of operations, casting is above everything else. So the first thing it would do here, it would cast, it would make total an integer. What's 1.59 made into an integer? 1. Just get rid of the decimal, right? So it's 1. Times 100, 100. But then we have 100 pennies. We don't have 159 pennies. Does that make sense? So casting is important. Here, if I've got 1 divided by 3, 1 divided by 3 we know is 0, right? But guess what it's going to do before it does the division? It's going to make 1 a double, 1.0. Now it doesn't store it anywhere, but by putting the word double in front of that 1, it's going to treat it as a 1.0. What's 1.0 divided by 3? 0.33333333, that's my new total. It's going to be a decimal number. So you'll see these conversions here. Oh, by the way, that was correct as well. Good here? A few more coming in, and then, yeah, this is the last thing we're talking about with numbers, then I'll talk about CS Awesome here in a second. We also have constants in Java. Constants are values that don't change. And what do you notice about this variable that's different that we don't have in the other ones? Well, there's a few things. I declared a variable called nickel value, right? You'll notice that it's got the word final in front of it. Final means can't change. So that means whatever value I give it, I can't go back and put another value. Kind of think of it as a bucket, like with the value in there, but it puts a lid over it. That number now can't change, which is fine, because is the value of a nickel ever going to change in our code? Probably not, so we want to keep it as 0.05. Also notice that it's all capitals. That's just a convention. We tend to, if we see it in code, we know, oh, that's a constant, it's not changing. And then that's when we use the underscore there. So if we ever want to see, so if you see something in all caps and the word final in front of it, just know that that's I don't say a variable, because variable means it can change, right? It's a constant. It's an identifier that has been declared as a constant, and it won't be able to change. Yeah?
I have a question about the other side.
Sure.
I just took me a while to formulate. So as I told you before, I'm a C# coder. So for me, I chose number 2 because how I code is if I had the parentheses around all of it, it would say that's not identifiable name. So how does it know that total is the only the full identifier name that it's trying to capture? Versus like the name not being total times 100 is the name.
Oh, well, it won't take the time 100 as the name.
So
You
just
can't,
automatically.
well, because just to go back, when we talk about variables, you can't have other special symbols in the variable names.
So it just knows to stop.
So it knows that
Okay.
since the asterisk is the multiplier operator, it won't treat that as a variable name.
Okay.
As part of the variable name, yeah. So Java's very hard syntax rules when it comes to identifying variables that way. Yep. Good call. All right, so a couple of things just to this end of the first part, then we'll take like a 5-minute break because we're just past halfway point. After constant. So in CS Awesome, if you had a chance to look at this, CS Awesome is divided up into units, and the units have different sections. There's coding projects in there. There's what we call Parsons problems, which are put code in the right order. Play with CS Awesome as much or as little as you feel you need to. In fact, everything that we just did is covered in Unit 1. in CS Awesome, you'll notice, oh, variables and data types, expressions, compound assignment operators, that's that plus equals, minus equals, casting. And then at the end of every chapter, they have great multiple choice exercises and they explain why the answers are the ones they are, which are really, really good. Do as little or as much of that you feel you need to for some extra practice. You don't have to do any of it. But what we do have for you, this would be one of the 2 projects that are up there, is something called Cash Register. And let me show you what this looks like. It says you're going to copy this program, Cash Register, and then complete the code. And let the computer do the math for you. I'm going to show you what this is. Then you're going to submit your file and a screenshot of the output to eCampus. And I'll show you how to do that here in a second if you need to. So I'm going to pull up Cash Register. I'm going to pull up, whoops, over here. This is what's on eCampus. And it's a program that looks like this. It says a lot of comments in here, so it explains what's going on. Oh, look, there's a constant, quarter value. Might come in handy. It says we have 2 variables. We have a total and we have an item count. Total is record the running total of items that we're purchasing and how many items are being purchased. We set them both equal to 0. So we did that. And it says you're buying a coffee maker for $22.75. Add that to your total and increment your item count. So the first one we did for you. So what happens? I added $22.75 to my total, right? Plus equals. That means total equals total plus that. So I added $22.75. And notice item count plus plus, what does that mean? It means item count is now
Plus 1.
1. So 0 plus 1, now it's 1. So great, I have 1 item, total $22.95. Now it says you're buying a phone charger for $12. Add this to your total. Here's what you don't want to do. Don't go, oh wait, $12 and 22, that's $34.75. Total equals $34.75. You just did way too much work. That's why we have computers. What should you be doing? Total plus equals $12. How much is that? I don't know. The computer's keeping track of it for me. And then what do I do to my item count? Plus plus, same thing there. Can you do that now with a calculator? Great, now you have 3 items. Again, let the computer do the math for you. Just add it. Don't try to figure it out, pull out your calculator on your phone and figure out what the total should be. Now, the total is, oh, there's $1. What variable goes here? Think about it. I have 2 variables, right? I want to print out the total. So what should I print here? I'll give this one to you. It's total. Hey, what variable goes here for the number of items purchased? Don't tell anyone. Spoilers, do it yourself when you get home. All right, that's the first one. Now, it says, if I wanted to give you your change all in quarters, how many quarters? Oh, sorry, I missed up here. Your payment is $100. Can you calculate their change? Don't go pull out a calculator and do it and do all the math. Can you do the payment and how much do they owe? Where's that stored? How much is their current purchase total?
Total.
It's in total. So how could I calculate their change? We saw how we could print calculations, right? Remember we did like 7 minus 3 or we did first minus second, right? Can we do, what would the calculation be here? Payment minus total. Would that be how much change you're owed at that point? Great, you get calculated change. And then it says, oh, wait a minute. Your change, you want to give all your change in all quarters. How many quarters would that be? So could you do a different, that one, I'm going to let you try to play around with that. Can you figure out how many quarters that would be? You know how to get the change, and you know that 25 cents is the value of a quarter because I've got a value called quarter value up here. Can you use that to do a little calculation there to print out how many quarters you should be getting back? And you know what? You don't get 23.0 quarters back. You should just get 23 quarters back. So you might have to do something to get rid of the decimal. See what I'm saying? That's one of our assignments. Yes, ma'am.
So, like you said, I think when I did it get like 52.0. So I
Right.
should put the INT in front.
Maybe, I don't know. Try it. See
See
what
what I
happens.
just saw now.
I'm
Okay.
just saying. See? Now think about it. Now, I'm kind of, I'm not trying to, but think how much you just picked up tonight in the first, like, almost an hour of this class. A lot. So that means it's time for a break. So if you want a quick stretch, I'm gonna hit stop on my video, 'cause we're gonna do part 2.